Welcome back to Munro Live, and today we have a dead horse. This is the 2021 Mustang Mach-E, and we have talked about the Mustang Mach-E in several videos now. We've even already torn one down here at Munro about a year ago. So we've completely disassembled one all the way down to every nut and bolt. The reports from that teardown are available. This is, however, a different trim level from the one that we had torn down before. And I don't know if we had gotten to do an interior review of the previous version. We did a review with Sundberg Farrar of this vehicle, but we're gonna do another one. And this one, I'm a little happy about just because normally when we do the vehicle reviews, all I can do is talk about the superficial things that we see. We don't often have them completely disassembled so that we can look at how they did it. But I do have some parts off to the side from the one that we were able to tear down. I want to kind of show you how they go about doing these things. So let's get started. Now, when I'm looking at a vehicle, I normally have a very critical eye just because in my career, I've dealt mostly with high-end luxury vehicles. The quality level that you expect from a high-end luxury vehicle, we get beat up all of the time. So when I look at more of a mid-range or more of a normal car that everyday people are going to purchase and drive, I can be quite judgmental. And I admit that. But when I'm looking at this vehicle, I'm trying to look at the different elements of style that they've incorporated and how well they were able to execute with the different technologies and the different materials that they have selected. So there's a layering effect that goes into these constructions. We see a seat, which is wrapped with a vinyl and a artificial suede Alcantara material, highlighted with a copper piping, copper stitching, and you see the copper stitching carries over into the wrapped portion of the center console. Wrapped portion with the Prindle knob and also on the armrest. So they take a lot of high-end materials and spread them out throughout the vehicle. I like that. I like the comfort. I like the perceived quality or the perceived opulence of having those type of materials throughout. When we look at the IP, we have a fabric wrapped area which incorporates the speaker grille. We have a metal trim piece. We have another artificial suede wrapped component. So we have this layering effect that's in here. So hard plastic on top, fabric wrapped. This is a chromed piece, but it has a bronze finish, a decorative metal, the suede, and then plastic below. Now that carries from one side of the vehicle to the other, having that layered look. But let's look at the components that we tore apart. So first off, here is that fabric wrapped piece holding your speaker areas. This is the chrome trim, which is bronze in the one that we're looking at here. Then we have the metal finish, but this is actually just plastic. Now you'll notice here how this is peeling up. This is an in-mold film. They're able to load this film into the injection molding machine, back inject it to get this nice crisp front surface. All right, well, I like doing that because it's very minimal, but what about this? This is actually chrome. This entire piece is dipped into a chrome tank. It is chromed, and then they're heat staking that along this edge. Why couldn't they just use a film inside of this piece rather than having to go through the whole chroming process? Well, here's why. It's a matter of scale. Look at the size of this. If I'm using this as a die cut piece, I can handle this. I can load this into a machine. This, however, that is your only exposed edge. You just can't cut and handle something that is this long if that were a laminate. So I have to chrome that entire component. But let's look at this piece. That bronze chrome trim continues through the door, and it creates a separation between the upper and the mid portion of the door. All right, well, what's different about that one? This one, we see that they chromed the entire piece and then just heat staked it to the back of this component. But what about this piece? Let's take a look. All right, so here is that trim. On one half, we are going to have the lower or mid portion of the door. On one half, we are going to have the upper. These are going to be heat staked together. But look at the chrome. The chrome is only on that narrow band. It is not the entire component. How do they do that? All right, how do we chrome plastic? ABS, acrylonitrile butadiene styrene. That is the type of plastic that you can apply chrome to. Normally you have to acid etch it, eats away the butadiene layer, and then the chrome will attack what's left. What this part is, it's a two-shot. They have a main structure, which is polycarbonate. They two-shot the ABS over top of that. Here are the ingates from the second shot, and you can see the area that they allowed for that. Then, when they go into the chroming process, the chrome only attacks the ABS. So they have very minimal chrome that is actually being transferred through this process. It saves them money and then also that hazardous material. So we can get the chrome look on just the narrow area rather than chroming the entire component. So what about the times you have to chrome an entire component? Well, here's another trim piece that is chromed. The entire thing is chrome. But look at the size in comparison. Very narrow, very wide. This piece has to have attachment features for how it is assembling into its vehicle. Those attachment features have a fixed size. I can't really get them any smaller. So if I wanted a chrome detail on this vehicle, I am stuck with something of that diameter. I can't go any narrower. But with this process, I can go very narrow. So now look at this component. When this is assembled, it has a very narrow profile of visible chrome. That's all you will see. But because of the attachment tabs coming off to the side, they had to chrome the entire thing. Again, chroming a very large part just for a very narrow decorative band. I like what Ford did, and they did this in several places throughout this vehicle, minimizing the actual amount of chrome that has to go on the part by two-shot molding the component that the chrome is on. So let's look at the door armrest. We have that wrapped upper component again. We have the suede mid panel, and then we have a wrapped armrest. All right, what are the ways that we would make this component? This right here is most likely vac formed. This is molded, compression molded most likely to the panel. This is a wrapped component. So let's look at those panels on the table. Here's the mid panel that is suede in the vehicle that we're looking at today. You'll notice this is one big piece that is press bonded to this piece of plastic. The edges have to be wrapped, and they've gone ahead and they've stapled the corners. This material most likely has the adhesive already preset onto the back of the roll, and when they hot press it to the panel, glues itself down. This part can be automated. You can do this in a press tool, you can do this with automatic folding fingers, but then they have stapled the corners for security. You can get a nice, soft, cushy feel part in a high volume, low cost using something like this, but it is kind of boring. So this component is actually sewn. It's a real stitch on top of this material, but it only has one seam. Now the good thing about one seam is if I am wrapping this component I'm going to set the piece of plastic on a fixture. I have my cover. All I'm setting is one seam, trying to make that straight. Then I would pull out all of the edges and wrap around. You'll notice the blue tint to this. That means that this was a spray adhesive, most likely a water-based adhesive. So they had to actually manually spray this part, spray the cover, wrap them, wrap the edges. So you'll notice here, even though we still have corners, similar to the other component, there are no staples for security in these corners. I used to always try and develop my programs whenever I had a wrapped part with a water-based adhesive with no staples. If I had to throw in staples, I felt like I failed. But sometimes you have to. Because of the bulk of this material on these tight corners, they did staple them. This product with one seam could be a hybrid between manual and automatic wrapping. A person most likely would still have to set this seam, but then you can set this in a machine to do all of the rest of the wrapping for you.
Hey boys and girls, this episode of Munro Live is brought to you by our friends over at Henson Shaving. Here at Munro & Associates, we get excited about good manufacturing. The razor itself is made in Canada at an aerospace machine shop. The advanced machining allows the razor to be produced with incredibly tight tolerances. Those tolerances really matter when the blade exposure is so small. This very small amount of blade exposure eliminates cuts, nicks, and irritation. I really like the built-in channels. It's easy to clean with a quick rinse under the tap. The blades themselves are recyclable and only cost about $0.10. Turns out the blade wasn't the issue. It's how you support it that really counts.
So you'll notice the profile of the upper IP, how it has two pronounced areas. You can see that here. When we had our video with Sunberg Farrar, we had mentioned that that is actually a carryover from the original Mustang. Now, what this also enables, you have some vehicles that have this common reflected approach so that all they have to do is change out the front trim so that you can go between a right-hand drive vehicle and a left-hand drive vehicle. Now, it's not on this one. It is not a mirrored component, but that is a good way of being able to save tooling if you could have one component that works for both right-hand drive, left-hand drive, and just change out the sides that are necessary rather than changing the entire vehicle. Now for airbag deployment. We have a passenger airbag right here. This part is injection molded. This top is painted. You don't always have to paint your A-surface plastic components, but many people like the way it kind of dulls the surface. You don't get it really, really shiny. Sometimes you can use a soft touch paint so it feels a little better than just a direct injection mold. But here's your airbag chute. Now, there are different ways of doing these airbag chutes for airbag deployment. Sometimes you'll actually have a metal bracket that is an insert mold into your main component, and then you'll have a chute that actually bolts to that metal bracket. It's kind of an old style. We try not to do that anymore. This one is a chute that is welded to this main component after it is injection molded. Okay, so you'd have a polypropylene upper panel. Normally you would have a TPO chute because TPO will flex better than polypropylene. So the polypropylene outer surface cracks and breaks. The TPO hinge here holds the broken pieces together as it's flexing out of the way. But look, I don't see any score line. How did they do that? Well, they used laser scoring. And when you laser score, if it's an H door, sometimes you can get away with welding, and then you would laser score inside of your H. But with a U door like this, you can't get the laser head in here to score the outer profile. So they would laser score this component first, and then they would weld the chute on. So the score line is actually hidden underneath this outer edge. Now, that's good as long as you tune your process very well. I've had problems in the past in doing that. The energy of welding your chute to the outer surface ends up deforming and warping and causes a lot of read-through of your score line. You never want to do that. So let's go back to discussing these seats. All right, so Ford wants to use a common structure throughout their vehicle platform. It saves them money on both unique development for every vehicle. You really would not want to do that. And you get an economy of scale. But even though you're using the same structure, you still want differences between your program platforms. You can do that with the foam and you can do that with the trim. Now, this is a Mustang Mach-E and we tore apart one. But if you look at it, not only is the sewing different, but the foam is different as well. Look at the upper shoulders here, and now look at the other Mach-E. Now, if you were to do a cutaway here, you'll see how the shoulders actually come up to either side of the headrest. So, just by changing the foam and the cover, they can change the look of the seat without having to change the structure. So you're paying for foam tools and you're paying for sewing. Now, the good thing about sewing, the only tools that you have to purchase are your cutting dies, and cutting dies are really inexpensive, but you're gonna have to pay for a new foam tool. Now, the way the foam tools work is they are molded on a carousel, a big round wheel with a bunch of tools on it. You will open up the tool. There are inserts. There's Velcro, there's plastic snaps, there's wires. You will load those insert pieces into the tool. Someone's going to come in, inject the foam, the tool's going to close. It continues around the carousel, so a person is constantly loading pieces, injecting foam, loading pieces, injecting foam. As it's going around the carousel, the foam is expanding, the foam is curing, gets to the other side where someone can remove it. So unfortunately, you have to pay for a lot of foam tools every time you change your foam because you can't really do this process with just one. But it is just the foam tools and the cutting dies in order to completely reshape and change the look of the seat. Now, this might be somewhat misleading about the amount of legroom in the back. I've slid in the front seats as far forward as I could. I just want to show the seat backs and the mat pockets. You'll notice the mat pockets are all sewn into the seat cover. It's integrated right in. Here's the seat cover that we tore apart. Same execution. So, there are zippers going up and down each side. These zippers are hidden zippers right in there. After you wrap this component, you have snaps and other panels that secure the mat pocket that holds this nice and firm so that when I'm grabbing and tugging, I have security around this profile. Then I'll go in there with a hook and I will hook that zipper and pull it down nice and tight to close it out. This is a common execution that Ford uses across most all of their programs rather than having a integrated mat or a injection molded mat pocket. The only thing that I don't like about this, I just don't like the feel of that foam backed material inside of the mat pocket. Now, who cares about the feel of the foam inside of there? How often are you sticking your hand in there? Well, if you're saying how often are you sticking your hand in there, how often are you using a mat pocket in general? Why do we even have the thing if people aren't actually using it? That's just my own personal opinion. However, some of you may use yours all the time. Notice the GT logo, which is embossed into the center console. All right, the embossing, there's a couple of ways to do that depending on the type of material. If you're dealing with leather, you literally have a brass head that is the shape that you want, and with heat and vibration, it will set down and it will compress that leather. Some artificial materials cannot be embossed. The actual skin material is very, very thin and it has a fabric backing. The fabric backing does not react to the heat and does not thermoform, does not reshape itself. Some will emboss. Sometimes you actually have to use a vacuum forming process rather than just a press-on tool to get that shape. So I don't exactly know what this material is. Most likely it is a form of PVC. But it would have to have a thick enough skin in order to be able to be embossed. So what did I really want to say in this video? I wanted to talk about some of the technology, and I wanted to talk about the how. And the reason why I wanted to do that is because when you look at each of these different components that are stacking up on this IP, most likely those are all done by someone else. So someone will be in charge of doing the chroming, someone will be doing the injection molding with the film, someone will be wrapping. The speaker grill may have its own requirements. I have been in meetings at the OEMs with all of our suppliers together, talking about an instrument panel, or talking about some other complex component. And basically there'll be 30 of us in a room fighting. And we're all fighting trying to protect our component. The person who's doing this chrome trim is going to fight for the amount of profile and the attachment of the chrome trim to this speaker grill. The person who's doing the speaker grill is going to be fighting for the wrap radius around this entire edge. Too tight of a radius cannot be wrapped. Too big of a radius might also be an issue. The size of the speaker, how far the speaker can come to the edge. The person who's making that chrome must cut their piece of plastic away from that speaker because they cannot overlap. Whoever's doing the air vent is going to also be in that fight. We are all fighting over land, we're all fighting over resources when it comes to the interiors of a vehicle. Now, that is both good because you end up having experts on every single component who are fighting from their own point of view. But the problem is, all of those experts are selfish. They may or may not care what happens to the other components around them. So having a good engineer at the OEM who can bring all of these components together and who can settle disputes between each of the suppliers who are doing all of these different components, that is key to the success of any automaker. You really need to be able to be political and negotiate around all of those points. You can't have everything that you want, unfortunately. There are trade-offs. And literally 30 people in a room fighting hours over movement of a millimeter between faces of components. I've done it in the past. It seems like such a waste, but it has long-term effects for the entire life of the vehicle. So let's quickly look at the wireless charging. So you'll notice that we have the logo on this side of the center console for your wireless charging. Let's take a look what's underneath that. I was actually kind of surprised that they hid a Mustang logo underneath this piece of plastic. Not opposed to it. It's basically free in the injection molding tool, but that's kind of odd to be hidden. But here's the point where your wireless charger is. What this has is a bunch of coils in it that need to be uniquely aligned to your device. Now, I worked on some wireless charging in a research group several years ago, and that was one of our difficulties is your phone had to be positioned accurately for the charger to be effective between the two components. So you have a requirement of the thickness of materials that those coils can go through. So the thickness of material between my phone sitting here and those charge coils, and also the positioning. So that is why these tabs are important. They help to hold your phone in orientation to the coils that are inside of that charging device. So I hope you've enjoyed hearing some of my thoughts on the interior of the Mach-E, more so the technology and the how on how they were executing this interior. It's a lot of different people working from a lot of different angles to get something that really looks very, very nice. Now for me, my own personal opinion, which I think I've shared before, I don't like black interiors. It's just too much black. I like something lighter. But that's my own personal opinion. That has nothing to do with the quality of the interior or the quality of the vehicle. So thank you very much for watching. Please subscribe if you have not. And as I said, we have already torn down one of these Mach-E's, and we have reports that go through every system of the vehicle. You can purchase those reports to peruse yourself, or if you're thinking or designing a vehicle yourself, you can kind of get an idea of what it took to go into that, what it cost to make something like that. So thank you very much.